Hello students, in today's class we are going to discuss about PMMC instrument. Then we are going to discuss about PMMC in measuring instrument. What is PMMC? P for permanent magnet moving coil instrument. PMMC. P for permanent, M for magnet, M for moving, C for coil instruments. One of the most accurate type of instrument used for DC measurement is PMM instrument. We can say it is one of the most accurate type of instrument which is used for measurement of DC direct current in PMMC instruments. Then the moving coil and permanent magnets are the main part of the PMMC instruments. The parts of the PMMC instruments are explained below. We are going, in the next part of this section we are going to discuss about the construction of moving permanent magnet moving coil instruments. Then the moving coil and permanent magnet are the main part of the PMMC instruments. The parts of the PMMC instruments are explained in this part of this lecture. The constructional features of these instruments are shown in the figure, and the moving coil is wound with many turns of enamel or silk covered copper wire. The coil is mounted on rectangular aluminium firmer which is pivoted on the jeweled bearings. The coil moves freely in the field of a permanent magnet. Most voltmeters coils are wound on metal frames to provide the required electromagnetic damping. Most ammeter coils, however, wound on a non-magnetic formers because coil turns are effectively shorted by the ammeter shunts. The coil itself therefore provides electromagnetic damping. The coil is the current carrying part of the instrument which is freely moved between the stationary field or the permanent magnet. The current passes through the coil deflects, due to which the magnitude is of the current or the voltage is to be determined. The coil is mounted on the rectangular form which is made of aluminium. The coil is mounted on the rectangular form which is made up of aluminium, and the coil is wound with silk covered copper wire between the poles of the magnet. Then the parts. What are the parts of a PMMC instrument? These are the permanent magnet, rectangular coil, controlled springs, aluminum cylindrical core, pointers, pivots, scale, dust-proof case, etc. This shows the internal diagram of a parts of a PMMC instrument. This is the pointer, this is moving coil, permanent magnet, this is core, lower control spring, upper control spring, soft steel rings. These are the parts of the PMMC instruments. Next, coming to the part, we are going to discuss about what are the working principle of operation of PMMC instrument. What are the working principle of PMMC instrument. In this next part, we are going to the discuss about the parts of the PMMC instruments in details. Next, going to the magnetic system. Old magnet system consisted of relatively long U-shaped permanent magnets having soft iron pole pieces. Owing to the development of the materials like alcomax, alnico, which have a high core surface force, it is possible to use smaller magnet lengths and high field intensities. Next, the control. When the coil is supported between two jewel bearings, two phosphor bronze hairsprings provided to control the torque. In PMMC instrument, the controlling torque is because of the spring. The springs are made up of phosphorus or bronze and placed between the two jewels of the bearings. The spring also provides the path to lead current to flow in and out of the moving coil. The controlling torque is mainly because of the suspension of the ribbon. The springs also serve to lead the current in and out of the coil. This method is comparatively new and claimed to be advantageous as it eliminates bearing friction. Next, going to the part deflecting coils. Deflecting coils. The coils rectangular in shape, wound on aluminium former with large number of turns. Width of the rectangle is less than distance B by W poles of PM with an air gap. This diagram shows the deflecting coils and the jewel bearings. Next, aluminium core. A light aluminium cylinder with pivot at the top and bottom side of fit over the axle of moving coil and acts as a damping mechanism. Here, next come to dust roof cases. The whole instrument is enclosed in a dust roof case. The shapes and size of the case depends upon the capacity of the instruments. Then coming to the working principle. PMMC instrument works on the principle of DC motor. When current passes through the coil, it produces flux of the core. When a DC supply is given to the moving coil, current flows through it. When the current carrying coil is kept in the magnetic field, it experiences a force. This force produces a torque and the former rotates. The pointer is attached with the spindle. When the former rotates, the pointer moves over the calibrated scale. When the polarity is reversed, a torque is produced in the opposite direction. The mechanical stopper does not allow the deflection in the opposite direction. Therefore, the polarity should be maintained with PMMC instrument. If AC is supplied, a reversing torque is produced. This cannot produce a continuous deflection. Therefore, PMMC instruments cannot be used in case of AC circuits. It is applicable for only DC circuits. Then torque in the PMMC instrument. The torque moment or moment of force is the tendency of a force to rotate an object about an axis or pivot. The deflecting torque is equal to total force into distance. That implies TD. We denote deflecting torque as TD. TD equal to NABI. N is equal to number of tons N is equal to number of tons, B is equal to flux density, A is equal to area of cross section, I is current. At the final deflection, TD equal to TC. That implies TC controlling torque proportional to the current. Here damping is issued by eddy current damping. Here the damping valve is eddy current damping. Next, going to the part of advantages and disadvantages of PMMC instruments. The PMMC consumes less power and has great accuracy, and it has uniformly divided scale and can cover arc of 270 degree. Next coming, it can be modified as a ammeter or voltmeter with suitable resistance. The PMMC has a high torque to weight ratio. It has efficient damping characteristics and is not affected by a stray magnetic field. It produces no losses due to hysteresis. These are the advantages of a PMMC instrument. Then coming to the part of disadvantages. The moving coil instrument can only be used on DC supply, as the reversal of current produces reversal of torque on the coil. It's very delicate and sometimes used as a circuit with a rectifier. It's costly as compared to the moving coil iron instrument. It may show error due to loss of magnetism of permanent magnet. You may also read minimize the risk of electrical shock on ships. Then coming to the part, what are the errors in PMMC instrument? In PMMC instrument, the error because of the aging and the temperature effect of the instruments. The basic source of errors in PMMC instruments are friction, temperature and aging of various parts. To reduce the frictional error, ratio of torque to weight is made very high. The most serious errors are produced by the heat generated or by changes in the temperature. This changes the resistance of the working coil, causing large errors. In case of voltmeters, a large series resistance of very low temperature coefficient is used. This reduces the temperature errors. The aging of permanent magnet and control spring also causes error. Opposite errors in PMMC is caused by weakening of magnet and spring causes the weakening of magnet causes less deflection, while weakening of control spring causes large deflection for a particular value of current. The proper use of material and pre-aging during manufacturing can reduce the errors due to weakening of control spring. This is all about PMMC instruments.